We will now discuss topic 11.2a, Introduction to Organic Chemistry, Alkanes. On this title slide, you see a group of alkanes. They are the first four alkanes in a series of alkanes called a homologous series. If you'll note, all of them have single bonds between the carbons and single bonds between the carbons and the hydrogens. The assessment criteria for this unit is as follows. You need to be able to use and understand the IUPAC, International Unit of Professional and Applied Chemists, nomenclature for naming compounds. Understand why isomerism occurs and be able to draw isomers. You understand the formation of sigma and pi bonds and know their occurrence and implication for molecular shapes. Then we'll talk about alkanes as fuels, what happens with combustion products of alkanes and the environmental effects of burning hydrocarbons, and also homolytic bond fission and the formation of free radicals. There are some simple rules for naming compounds. They become more complex as the compounds become more complex. The first thing we need to do is to find the longest carbon chain. If you notice in the IUPAC names of unbranched alkanes at the right, they name them based upon the number of carbons. 1 methane, 2 ethane, 3 propane, and the like. Well, let's take a look at the numbered alkane on the right. What do you see? You see the longest carbon numbered. Now there is an additional carbon, but that, if you counted the number of carbons, starting with that one, the unnumbered one, you'd either have 1, 2, 3 for a carbon length, or 1, 2, 3, 4 as a carbon length. So we'll choose 4 as the longest chain. Are there any substituents other than hydrogen on that carbon chain? At number 2, there's a carbon with 3 hydrogens. If it were 4 hydrogens, it would be called methane. With 3 hydrogens, it becomes a methyl group. So, how would you name this compound? It is a 1, 2, 3, 4 butane, but at the number 2 position, there is a methyl group. So it would be called 2-methyl-butane. Let's name this one. What's the longest carbon chain? 3 carbons. They are all single bonds. The substituent here is not a methyl group, it's chlor. The chlor is on the first carbon. Count the carbons. The chlor is either on the first carbon or the third carbon. We choose the lowest number that the substituent is on. So the compound is 1-chloropropane or chloropropane. Isomerism occurs when you may have the same molecular formula but a different structure. Stereoisomerism may occur when you have the same molecular formula, but the atoms are in different places spatially. We'll look at the first and easiest, a structural isomer. Look at chloropropane again. Can we make an isomer out of chloropropane? If we put a chlor on the third carbon, is that an isomer of chloropropane? No, it's only the chloropropane molecule looking at it from the other direction. How about putting it on the second carbon? Is that an isomer? Yes, it's an isomer. It has the same number of carbon, hydrogen, and chlorine as the original, but they're just in different places. Now, sigma bonds are those single bonds that we saw in the chloroalkane molecule, whether they were between carbon and hydrogen, or carbon and carbon, or carbon and chlor. Sigma bonds are formed when hybridized orbitals overlap each other. Now, if we have another type of bond on top of a sigma bond, we call that a pi bond. A pi bond is formed by an overlap of atomic orbitals. We'll see in this term overlapped unhybridized p orbitals, which are perpendicular to the hybridized s orbitals. The pi bond orbitals are weaker than sigma bonds. Take a look at the table on the right, stop the video, and look to see the 7 bits of information for both sigma and pi bonds. Now, here is an actual picture of ethylene, ethane with a carbon-carbon double bond. You see that we still have the carbon-carbon sigma bond, but we have 2 p orbitals overlapping to create a pi bond. Alkanes are used as fuel. Their combustion products are what's left after we burn that fuel. Natural gas is predominantly methane with some other alkanes. Liquefied petroleum gas is usually propane and butane. Petrol, gas, kerosene, and diesel are used in transport. They're found, or they are made by taking crude oil and heating that crude oil and taking off each of the products based upon their boiling point. Let's look at a video that outlines the combustion of alkanes and their potential reactions.
MSJ Chem, in this video I'll be looking at the reactions of the alkanes. Alkanes have low reactivity. This is due to 2 reasons. The first is the carbon to hydrogen bond is a non-polar bond. The second reason is the carbon to carbon and the carbon to hydrogen bonds in the alkane are strong. This can be seen by looking at the average bond enthalpy values, which you can see here. So alkanes have low reactivity for these 2 reasons. However, they do undergo chemical reactions, which we'll look at next. Alkanes undergo combustion reactions. In a combustion reaction, an alkane such as propane reacts with oxygen to form carbon dioxide and water. In complete combustion, there is an excess of oxygen and carbon dioxide is produced. In incomplete combustion, there is a lack of oxygen and this produces carbon monoxide. If the amount of oxygen is very limited, then carbon will be produced. So the two kinds of combustion are complete combustion, where there's an excess of oxygen and carbon dioxide is produced, and incomplete combustion, where there is a lack of oxygen forming carbon monoxide or carbon.
Through that video, you were able to see the use of alkanes as fuels and their combustion products, or should I say incomplete combustion products. In addition to the primary pollutants, we can have particulate matter as well. Now, burning hydrocarbon fuels is what we currently use to power our economy. There are advantages and obviously disadvantages. It's expensive if we want to change from hydrocarbon fuels to other alternatives. And those other alternatives tend not to make as much power as burning hydrocarbons. What are some of those other alternatives? Solar energy, wind energy, the use of ethanol as a part of our hydrocarbon fuels. The last topic that was briefly discussed in the video was homolytic bond fission and the formation of free radicals. That's the breaking of a bond that results in one electron going to each atom in the bond. It's caused by light and the effect of the frequencies of light on the bond between two covalently held atoms. These species are called free radicals and they are very reactive.
Alkanes also undergo substitution reactions. Substitution reactions occur in 3 steps. The first step is initiation. This occurs in the presence of UV light. In the initiation step, a chlorine molecule, which is 2 chlorine atoms joined with a single covalent bond, breaks up in the presence of UV light to form 2 chlorine free radicals. Free radicals are species with an unpaired electron. This makes them very reactive. This is known as photochemical homolytic fission. The bond between the chlorine atoms is split by UV light, with each chlorine atom taking 1 electron. The next step is propagation. In the propagation step, methane reacts with a chlorine radical to form a methyl radical and hydrogen chloride. The methyl radical then reacts with molecular chlorine to form chloroethane and another chlorine radical. As free radicals are produced in the propagation step, the reaction is known as a chain reaction. The final step is termination. In the termination step, the free radicals pair up their electrons to form molecules. In the first step, 2 chlorine radicals react together to form chlorine. In the second step, 2 methyl radicals react together to form ethane. And in the final step, we have a methyl radical and a chlorine radical reacting together to form chloroethane. And finally, here we have the overall equation for the reaction. So that's methane reacting with chlorine in the presence of UV light to form chloroethane and hydrogen chloride.
There are some questions to start your thinking. Please take advantage of these questions to help you process what you have watched or prepare for me to have checked before you retest on this topic.